Hello and welcome to lesson 4.5, trigonometric functions. Today we're going to look at some inverses of trigonometric functions and use what we've learned so far to actually find out when a function is calculated within its domain to actually find all possible solutions to any kind of function. Well, due to the fact that the actual function y equals sine inverse of x isn't actually a function, it's actually a relation. Y equals arc sine x is actually a function and is given by this drawing right here. So this is sometimes considered y equals sine inverse of x as well, and that would be a function, whereas x equals sine y is a relation, so it's not a function, and therefore it's only defined on this specific domain between -1 to 1 and this range between -pi/2 to pi/2. Likewise, we have arc cosine, or also called y equals cosine inverse of x. Likewise, we also have the arc tangent, or also y equals tan inverse of x. We also have cosecant, arc cosecant or arc of cosecant inverse of x. There's also arc secant of x, or also y equals secant inverse of x. And last but not least, there's also arc cotangent, or y equals cotangent inverse of x. These functions are not necessary to remember what they actually look like, but just the fact that they are only defined within a specific domain, and usually that domain is either between -pi/2 to pi/2 or 0 to pi. So what we're going to do is we're going to use our skills that we know in order to solve these kinds of questions right here, so that we can find the solutions on all the domain between the values of -pi/2 and pi. Between -infinity and infinity. So let's solve these. So the first thing to do is to change them so that you just get the sine x, cos x, or tan x, or whatever function it is by itself, and rearrange. Okay, so now we're going to solve for the value of x by taking the sine inverse, or arced sine, of 3/5. So this is nothing different. You calculate this on your calculator. So on our calculator we get 0.644. Now again, remember that sine is only positive in 2 quadrants. And the 0.644 is the one we found. So to find the other possible solution, all you do is take the value of pi and subtract 0.644. So that is approximately 2.498. Well, these are only 2 solutions within the full 360s, or from 0 to 2 pi. Now, because this function right here, sine of x, actually has a period of 2 pi units, the next set of solutions can actually occur 2 pi units away. So to list all the solutions, we take our current solutions of 0.644 and we add multiples of 2 pi, where the value of k that I've created here is an element of the integers. So this is all the solutions to this expression. So let's try the next one. We're going to make tan x equals negative 1/4. And again, we're going to take to solve for x, we're going to take the tan inverse of negative 1/4, also again called arctangent. My calculator automatically spits out a negative value of 0.245. Well, tangent is negative in 2 quadrants. It's, negative in the second quadrant and in the fourth quadrant. So this angle that we've actually found is negative 0.245. This angle right here. So to actually find the angles on your regular domain between 0 to 2 pi, what we're going to do is we're going to take the value of pi and subtract 0.245, and we're also going to take 2 pi and subtract 0.245. So this gives me a value of approximately 2.897 and another value of 6.038. So that means now we have solutions we can have listed for all values of this expression. Now tangent actually has a period of pi units. And you could have actually seen this just because the fact between these two values is addition of pi. So actually you can list just these solutions. We'll just use the first one as a reference, so 2.897 plus any multiple of pi, where again k is an element of the integers. And that gives you all the solutions that you could possibly have. And thus concludes this lesson.